guys enjoying your AWS this week? Yeah? Cool. My name is Amy Mackey. I'm a director at AT&T for our Alliance team. I work with AWS Strategic Alliance. And with me today is Chris Perrell. Chris is an enterprise architect at AT&T. So first, thank you all for coming. Really appreciate it. Our topic today is cloud networking and how to connect from end devices to the cloud fast with high performance. So you all heard about some great new capabilities from AWS today, right? Great new features. But if you really think about it, without the network, there is no cloud, right? Pretty much, right? So, we think about that all the time at AT&T. Our customers think about that all the time as well. And in fact, as enterprises are consolidating, closing down their data centers, moving their workloads to the cloud, they no longer have those workloads running on-prem where they used to be able to see them, performance was all on net. Now they're up in the cloud, and they have to think about the network. How is the network performing? How does it impact the workloads? And some customers may be using the internet, right? But is that a good idea, right? It's best effort. So applications are impacted by congestion on the internet. It exposes that data to security risk, right? And so AT&T and AWS joined forces to create an end-to-end solution for our enterprise customers that securely connects the customer to their AWS resources on a private network, but not just private, right? We created a solution that is simple, fast, agile, and scalable, and very cost-effective. And that solution is called AT&T NetBond with AWS Direct Connect, all right? And this afternoon, I'm going to talk to you a little bit about the business value proposition, how customers are using it, and then Chris is going to go into the technology. How did we create it? How did we do it, right? So with that, let me kick it off with some trends that we all are seeing, right? First, cloud. Obviously, cloud, huge. We're seeing clients using, 40% of clients using multiple clouds, hybrid clouds. It's a huge way that customers are transforming their business. Mobility. By the end of next year, 50% of enterprises are going to have BYOD policies, right? And then IoT, 29 billion connected devices today, growing to 50 billion by 2020. And then security. So when everything was on-prem, we sort of understood the perimeter of the security, right? It was our building, right? We knew how to secure the perimeter of our building. But now, when data is on devices and in the cloud, that whole security solution really changes, right? So technology obviously offers a ton of benefits to all of us, how we deal with our clients, how we help our clients. But for many, it also introduces some challenges. So how do you connect all these disparate devices, right? How do you integrate to all the different cloud solutions out there? And then with the fast pace of innovation, how do you keep up with the innovation? And then lastly, security. What are the statistics? 117,000 cybersecurity attacks a day on the internet. Distributed denial of service attacks have increased 62% over the last 2 years, right? So it is tough, right? It's if you're an executive at a company and you're responsible for the security of your employee data, your supplier data, there's a lot of risk. So again, what our customers have been telling us is that, hey, we definitely need the agility, the cost effectiveness, the elasticity of the cloud, but we also need what we had when it was on our data centers and in our corporate prem. We need the control, the security, and the performance. And so we created a solution that delivers both. And this solution extends a customer's existing MPLS private network into the cloud and makes the customer's cloud services look like another node within their private network, all on net, right, off the internet. And again, we call that AT&T NetBond. So traditionally, or the way an enterprise did connect into the cloud is they would hub all the traffic to a corporate data center, right? Hub everything to a corporate data center, so creating some hairpinning effect. Put in big honking firewalls that they have to manage, and then they might put private line connectivity, create big private static connections into a cloud, and then at the end of that, or they might use the internet, right? And so what's the problem with that? What's the challenge with that? First, you have potentially poor performance because you're hairpinning through one corporate data center. You're still using a best effort internet. And it gets very complex as you connect to multiple clouds in multiple regions. Think about doing that over and over again and managing that. If you contrast that with what we do with NetBond and Direct Connect, AWS Direct Connect, we create a complete seamless private highway between end devices and the cloud. No hairpinning, direct connection, off the internet, very scalable. And we're going to go into how we did that and how customers are using that today. But before we do, I'm going to just play a quick video, and then we'll talk about a little bit more about it.
Imagine your business at the center of a highly secure cloud ecosystem, where your mobile workforce and all your corporate endpoints, from IoT devices to computing, are working in tandem with the clouds and cloud to cloud. This is AT&T NetBond. It connects your business to a growing cloud ecosystem built on the backbone of a global network. NetBond seamlessly integrates across leading cloud providers while maximizing performance and reducing latency. Orchestrated APIs and clouds connecting to clouds give you tools to access and optimize all your resources and applications, from file sharing and data storage to your CRM and other best-in-class cloud services. NetBond helps protect your business from attacks over the internet by routing your traffic through a highly secure connection from your VPN directly to your cloud. By bonding your AT&T VPN to your cloud provider, you have the network security, performance, and control you need to connect from nearly any device, anywhere, anytime. You'll easily provision and manage cloud resources and scale your network on demand. So as your business expands, you can do more, from growing your capabilities to leveraging cloud innovations that help you get to where you want to be. AT&T NetBond. The future of the cloud is yours.
Okay, so the foundation of this service is our global Mpls network. How many people use or know what an Mpls network is? Oh, fantastic. That's good, good. Assumed you all did, but just wanted to check. So AT&T has one of the biggest networks in the world in over 197 countries. We support about 107 petabytes of information every day. We've been doing this for a very, very long time. So you can think about we have a global network, right? Customers have been running, enterprise customers have been running their traffic on it for decades, right? And so what we've done with NetBond is actually opened up Fort Knox, and we have created an integration with the cloud. So essentially, we are extending a customer's existing MPLS into the cloud. So foundational to NetBond is the MPLS backbone. And then what we did is that we actually, the folks down in Middletown, New Jersey, our ATO folks, created NetBond with some patented technology, some advanced routing technology, some APIs, and very importantly, software-defined networking. So NetBond is actually AT&T's first offer of software-defined networking. We actually launched this in 2013, by the way. That was the first instance of NetBond. So when you hear about software-defined networking, you can think about NetBond. That's exactly what it's based on. And let me tell you a little bit about how we created it, and then Chris is going to go into a lot more detail. So fundamentally, again, the MPLS network, but what we do is that we create meet-me points with our cloud solution providers. In this case, we'll talk about Amazon Web Services, but we actually have a whole ecosystem of cloud providers that we've integrated with. Why? To give our customer choices. But what we do is we create a meet-me point, an interface with our cloud solution provider. around the globe. And essentially, that is a physical connectivity. We hand off N by 10 gig connections, right? 2 of them, primary and backup. So we have full redundancy built in from the get-go. So we've built the physical connectivity, right? We built it. It's ready for you to use at any point, fully scalable. So you don't have to outlay any capital. You don't have to order any routers. You don't have to wait 120 days for physical connectivity. It's available on demand. But that's just a physical connectivity. The beauty and the intelligence of NetBond is actually the orchestration layer. So again, all these smart guys and gals down in Middletown, New Jersey created NetBond. It's an AT&T created service. And what we've done is through a self-service portal, we allow an end user, a customer, an enterprise to go into that portal, and with just a few pieces of information, they can create a virtual network container or connection to the cloud provider of their choice. So they go into the self-service portal. They indicate from a drop-down menu which cloud do they want to connect to, which provider. Where in the world do they want to connect? What region do they want to connect into? And then they select which VPN they want to connect to. They go to the next screen. They create their first virtual LAN with that provider. And they do that very easily. They just say, what do I want to call it? And we're going to see a demo of this. What private IP address space do I want to use? Right? And they hit submit. And the behind the scenes, we make API calls with our partner, and we have a NetBond orchestrator that updates the route tables for both the customer's AT&T routers and the CSP routers. So in real time, we have propagated the new route for that customer, and automatically now, every site on that any-to-any mesh network can see their new cloud resources as if it's a new service or a new node on the network in real time. So you guys know Mpls. How long does it normally take to order an Mpls circuit? It takes a while, right? How hard is it to integrate it to a cloud solution provider? That's not easy either, right? What we've done is create a fully managed service that allows you to create that connectivity in minutes. But the beauty of it is every single connection you do to any cloud provider is the same exact experience. So it's a 5-minute creation of a virtual network connection to any cloud provider you want. And then you can manage that all through the portal. And then you select which bandwidth you want. You can start at 1 meg, go all the way up to 5 gig, but it's full burstability, and the bandwidth moves in tandem with the cloud resources. So you don't even have to guess what your bandwidth is going to be. So very scalable. So let's talk about some of the benefits and how customers are using this. So, performance. Performance is what we mean by is on net, it's predictable. You know how that performance is going to be for your workloads. But let me give you a couple examples. So we have one customer who is an international company. They have call centers around the world, but their customer information is located in the cloud in the US. And what was happening is they were using the internet across the globe. When a call came into a foreign call center, they were not able to get the customer profile information in time to actually service that customer. So what they did is they moved it all to the Mpls NetBond connection, and when a call comes in, let's say to Australia, then that customer information is available in real time to that call center agent so they can service the customer. So that's an example of global performance on an Mpls network with NetBond, right? Performance can also be in how quick you get the availability of the resources. So we have a global real estate company, and they were making a move to the cloud, but the issue was they didn't know how their application was going to work in the cloud. So they were going through a development test cycle, right? So they had a small bandwidth for the development and test, and once they were ensured that it was working correctly in the cloud and they were moving to production, then their bandwidth just scaled automatically with them. They didn't have to move the application, it just moved automatically with them. So that's a couple examples of performance. So security. So we have a lot of enterprise customers who really care about the protection of their data, right? We have large entertainment company, and they collect a lot of client information. So it's very important for them that that information is secure, right? And that's why they're using NetBond. We have a lot of healthcare and financial companies on the service. And again, it's so critical, right? They can't take the risk of using the internet. They just simply can't take the risk. So they're keeping it on net, private within their network, right? And by the way, one thing we're seeing is that when people do use private connectivity, the AT&T NetBond to direct connect, that they're actually using a lot more compute resources, right? So that's important, right? That they're actually using more when they feel confident about moving to the cloud. Another use case, you heard about hybrid cloud. Well, we've been doing hybrid cloud for a very long time. In fact, one of our very first customers on NetBond, one of the largest appliance companies in the world, that's exactly the scenario. They have a web-based facing application, but they needed to dip back into their inventory system sitting on-prem. Well, the inventory system is sitting on an Mpls backbone. Their cloud application is now connected to NetBond. So they're all on net, right, for that hybrid scenario, which is critical, right? Because as that transactions go back and forth, they need that on-net performance. So that's one use case. Simplicity is really, really key, right? So we had a company that had they knew what they were doing. They had a pretty intelligent IT staff, but they had internet connections and IPsec and SSL going all over the world. And they said, simply, we do not want to do this anymore. We don't want to manage that complexity, right? We're not in the business of managing internet connections and SSL. So they moved to NetBond because it's a single pane of glass, right? You can spin up VNCs when you're sitting on the beach if you wanted to, right? Very, very, very simple, right? And so that's why they moved. We had another energy company who they had a very small IT staff, and they were moving to all as a service. That was their, we were moving everything to as a service. And so they wanted this for the simplicity of being able to spin up these VNCs. Another big value is control. So some enterprises have, guys and gals that go around using a credit card, shadow IT, to spin up kind of internet connections, whenever they want, right? So we had a very large company that, an insurance company, that had multiple lines of businesses, right? And we have a capability within our portal that allows an enterprise to bring up sub-accounts. So this company loved the idea to be able to assign sub-accounts to all their divisions, right? And that way the divisions had autonomy, but they also had, the company itself had oversight, right? So they liked all the other value props, but they loved the control value proposition, right? That's why they actually got the service. So that's a really, really important thing. We talked about the elasticity. NetBond, the bandwidth expands just like your AWS resources up and down, right? Really key for seasonality. At AT&T, we do our fourth quarter, and for fourth quarter, we do our HR benefits, right? So you can imagine the spike into our systems in the fourth quarter. That bandwidth can go right up when it needs to be and right down. But you can see that across all verticals, right? All verticals have that seasonality when they need to go up and down on the elasticity. And then last is cost effectiveness. So again, you're not outlaying any capital. What you traditionally did, you might build a private line, and you have static connectivity that you may or may not use. Now it's delivered in as a service, so you're paying just for what you need, just when you need it, right? And that bandwidth will flex up and down as your workloads go up and down. So I think I covered a lot of the value propositions. There's more, but I just wanted to give you a taste. Oh, I have one really more cool one. Can I do one more, because this one is my favorite. So this is a large, one of the largest wealth management companies in the world. And they had divisions around the world. And it just so happens that their division in Asia and their division in North America were both moving to the cloud. And independently, these divisions picked NetBond to make that transformation. They had a new IT vice president that came in, and her goal was to consolidate their data centers around the world and to consolidate their systems. So the wealth management, what's key to them is net intelligence, right? So they want to integrate the intelligence of all their systems around the world to make better decisions. And because these two divisions independently chose NetBond, they were able to make that integration much quicker, the integration of that net intelligence around the world as they consolidate their data centers. So I thought that was a pretty cool use case. So anyway, so let me move on. We're going to play one more video.
Today, customers can use AT&T NetBond to seamlessly connect their AT&T virtual private network to cloud service providers for the delivery of business applications through fast and highly secure connectivity. With a software-defined networking platform at its core, AT&T NetBond can put the power of these capabilities directly in customers' hands. This demo will show how easy it is to make that connection to Amazon Web Services using AT&T NetBond. The Customer Cloud Administrator goes through a few simple steps in the AT&T NetBond portal to prepare a cloud connection to Amazon Web Services. They begin by creating a new VNC. They choose Amazon Web Services from the cloud provider list. They then select a location to which they'd like to connect and provide a name for that connection. They choose their network from the drop-down list, select the desired bandwidth commitment, and click Create. As we can see, the VNC was created successfully. The next step in the process is to configure the Vlan connection. They first provide a name for the connection and provide IP addressing information from their network. They then enter the Amazon Web Services account ID. Route management functionality is available if needed. Otherwise, they simply click Submit. The Cloud Administrator is now ready to configure the Amazon Web Services Cloud to connect to AT&T NetBond. They begin by accepting both the primary and secondary connections. They do this by selecting the primary connection, agreeing to the data transfer terms, and clicking to accept the virtual interface. They then choose a virtual gateway. Finally, they repeat these steps with the secondary connection and click Accept. As we can see, NetBond access is now available. The customer's AT&T Virtual Private Network is now connected to the Amazon Web Services Cloud, so that employees can access their applications from any location and on any device. The AT&T NetBond platform, providing businesses with highly secure and flexible access to cloud-based applications, empowering customers to be more agile and efficient across the ecosystem. A smarter networking experience, only from AT&T.
Okay, so it really is that simple, but because we're AT&T, we like to white glove everything, so we actually walk the customer through all that, even the AWS piece of it. But it is really, really that simple. So I'm going to kind of hurry up here so I can give it over to Chris real quick. So we meet Amazon Web Services, VPC, public, the storage. We meet them in North Virginia, Northern California, Oregon, Frankfurt, Sydney, Singapore, Ireland region, and we are moving to Tokyo. So wherever our partner goes, we are going to meet them there locally as well. And then I think I just have two more slides, real quick. IoT, so we are partnering right now with AWS and IoT. We are a huge IoT provider. Think about most of the automobile companies use AT&T IoT. Red Bull uses it, some of the Formula One racing cars use it, Mirror's got the containers all use it. So now we're working with AWS to create, and we're demoing it right now actually in the IoT Center, but what we're doing is we're having automatic authentication authorization between our IoT platform and the AWS platform. So when you plug in that IoT device, it's going to automatically authenticate to the AWS platform all over cellular, not even Wi-Fi, all over more cellular, secure cellular network. So we can talk to you more about that offline. Really excited about that. We're demoing it now and going to be launching early next year. And the last thing I'm going to show is a use case, and this just is a fun one. This is Nest.com. It's one of our many customers. The brick and mortar company moving to the cloud, right? NetBond has been a huge help for them now. It has improved their ordering, their fulfillment processes, and really has improved their customer satisfaction. So this is a real fun use case. We have a lot more we can talk about. But in the interest of time, I'm going to hand it to my colleague, Chris. Thank you.
Thanks, Amy. Can everybody hear me okay?
Yep.
Okay, so Amy covered a lot. There might be a little bit of overlap, but mostly just to kind of set the technical context that I'm going to be covering. And so what I'm going to start with is I'm going to cover first the NetBond architecture that's specific to AWS, and then I'll move into sharing a few use cases that I found in my experience working with our NetBond customers. Excuse me. So there are two primary architectures for NetBond depending on the type of service that we're connecting to. First, I'm going to cover VPC. So on the left side of the slide, you see customer sites connected to an AT&T virtual private network. As Amy explained, that's an Mpls network. And just in case anybody in the room doesn't know, when I first started at AT&T, my background was actually more in enterprise architecture on the server side. So when I heard VPN, I'd always think, site-to-site tunnels over the internet. AVPN is actually a label switch network that's completely private. There's no components of it that ride over the internet. So that's called AVPN, excuse me. So the customer sites on the left connect to AVPN. They take the shortest path across the Mpls network to the infrastructure provider edge that you see in the middle. And that's really where the NetBond solution begins. The infrastructure provider edge could be considered the NetBond edge routers. And like Amy mentioned, AT&T has already acquired the colo space. They've deployed these enterprise-grade routers. They've deployed the switches, the cross-connect, so everything's in place. AT&T manages it. So there's nothing for customers to have to deploy. So once those peering connections are made to direct connect, then you ultimately get access to VPC. But I want to talk a little bit now about the orchestration. So for those familiar with network provisioning, NetBond follows the same customer edge, provider edge paradigm typically used to add sites onto a customer network. So it's all the same thing. The only difference is that NetBond does it programmatically via APIs. So all the physical infrastructure is in place, and what the NetBond orchestration is actually doing is carving out the VRFs, setting up the VLANs, configuring the interfaces, and establishing a BGP peering session so that routes can be exchanged. So anyway, sorry. So in order to do that, as part of the orchestration, the customer would have to supply a /29 block of contiguous IP space out of the Mpls network, or AVPN, in order for the orchestrator to actually split that into 2/30 networks to have enough IP space to configure the interfaces on each of those redundant peering connections. Okay. So next is what we call the public reference architecture. And this is used for all other Amazon Web Services. It's almost the same as VPC with two main exceptions. As you know, most AWS services were designed to be consumed over the internet in a SaaS type delivery model. So, and just like with your home network, you've got private IP space on the inside communicating with public IP space on the outside on the internet. And so what is happening is your home router, as you know, is using network address translation to make this happen. And it's the same thing with our customers that are using AVPN. Most of our customers are using private RFC 1918 IP space within their private network. And if they want to be able to connect to those endpoints for AWS services like EC2 Classic, S3, and IoT, just to name a few, then they need that component to do network address translation. Part of the NetBond orchestrator will actually provision a virtual network function to perform that NAT function. Its IP address comes from an AT&T owned pool of public IP addresses. So an IP address is assigned to that VNAT device that you see in the middle to perform the network address translation. So the other thing that's different about this one is that routing updates happen a little bit differently. So at this point, the Direct Connect edge routers don't need to know anything about the customer's private IP space because it sees the source IP address as that NAT IP address. So all we have to do at this point is advertise from the IPEs to the Direct Connect edge routers is that single NAT IP address. So you're going to see a single /32 at that point advertised to Direct Connect edge. But the VNAT device itself does need to have a full routing table how to get back to the customer site. So there is a BGP peering session that's established between the VNAT and the private side of the IPE so that routing exchange can happen. On the AWS to customer side, you're going to see a full advertisement of the full public routing tables that represent the AWS services. So I'm going to kind of skip over a little bit of this because we saw some of this in the demo video. But there are two main components that comprise a NetBond connection. Once a customer signs up to use NetBond, within just a few days, you get access to this portal. And the first thing that you need to do is create a VNC, or a virtual network connection, as you saw in the demo. The only thing I'd like to point out here is that a virtual network connection is a little bit misleading in that at this point we're not quite really making any connections. What we're doing is we're establishing a relationship between 4 key pieces of information. That is the cloud service provider that we're connecting to, the location where we're going to connect, the routing domain, so it would be private if we're connecting to VPC. It would be public for all other AWS services. And then the VPN that the customer wants to use to connect to that cloud resource. If a customer wants to create additional NetBond connections, and any one of these 4 things are different, then that would require creating another virtual network connection. Otherwise, and we'll talk about VLANs in a minute, you can create all the VLANs you want in the same VNC as long as those 4 things are the same. But regardless of those 4 parameters, there are going to be 3 other pieces of information that need to be entered. The first one can be ignored, community value tag. That is a deprecated route filtering feature that really shouldn't be on there. We've replaced it with something, and we'll look at that on the next screen. The bandwidth commitment, as we saw in the video, is a monthly estimate of the average bandwidth that a customer thinks they're going to use over a period of a month. And probably the biggest takeaway here is don't get confused. This is not a bandwidth limit, nor is it a bandwidth guarantee. Anybody who signs up for NetBond and creates a VLAN is going to be able to burst up to whatever theoretical maximum that cloud service provider allows. And they can change it at any time during the month. Oops, sorry about that. They can change that any time during the month. So if a customer goes in and sees they're actually using less than what they signed up for, they just slide that down. If they're using more than they signed up for, they can slide that up to best align for optimized billing. So once a VNC is created, and this part takes, 5 seconds, customer can assign a VLAN. So this is where we actually start making connections. What we need to provide here is a VLAN name. If we're talking about VPC, there's typically a one-to-one relationship between a NetBond VLAN and a VPC. So in my experience, it's best to name that VLAN whatever VPC you're connecting to. The direct subnet, we talked about the /29 that's required to come out of the customer IP space, that the NetBond orchestration is going to take that, split it into 2/30 networks, and configure the peering VLAN interfaces. Direct subnet prefix, it's a /29, can't be changed. Honestly, not sure why it's even on there. And the AWS account ID. So of course, when a NetBond orchestrator reaches out to the Direct Connect API in order to create the redundant virtual interfaces, it's got to have the account ID to associate it with as part of that API call. So this is a continuation of the VLAN creation. Excuse me. So NetBond also enables customers to do some route filtering using community value tags. So just in case anybody doesn't know what community value tags are, I didn't really know a lot about them until like 6 months ago. You could think of it as like a Post-it note that is attached to a route that's got a certain number on it. It kind of carries a value with it. So the first option here gives the customer the option of saying routes that are carrying a particular community value tag should be allowed to be advertised towards the cloud service provider. All other routes would be dropped. The next one is the reverse. It's a deny option. So all routes that carry a certain CV tag should not be advertised to the CSP, and all others would be allowed. The third one is an option to block the default route from being announced towards the cloud service provider. So if you've got internet egress somewhere on your AVPN, on your Mpls network, other than within the cloud service provider itself, and you don't want that default route to be used by VPC, then you can suppress that default route. The problem is with VPC specifically that if you've got more than 100 routes, VPC can only learn, Direct Connect edge routers can only learn up to 100 routes via BGP. And many of our customers have way more than 100. And if you try to advertise more than 100, the BGP session breaks and there's no connectivity at all. So what we've done is we have the IPE actually generate a default route and advertise that to the Direct Connect edge routers So you just have this one summary route so that you don't have to worry about that 100 route limit. So you can see here, if you suppress that default route, then you've got nothing. So there are a couple ways to get around that. One of them is the next option. This is a freeform field where you can enter a subnet or a route in CIDR notation that will be advertised to the CSP. So if you want to just advertise a couple subnets or maybe do a summary route, you can put it in here. That'll get advertised to Direct Connect Edge. And if you've got route propagation on your VPC route table, you'll see that. The other option is to just manually put in your routes in the VPC routing table. But you've got to have some kind of routing within VPC to make it happen. And then the last one is if you want to advertise certain routes from the CSP side towards your VPN, it's another freeform field in CIDR notation. You can put routes in there that'll be advertised. Any routes that don't match will be blocked. So, and Amy covered a lot of this, but I'll just be really quick. The thing that stands out to me, I'm a technical guy, but I think NetBond is pretty cool, is that NetBond has finally brought network into the realm of true cloud services. So, with compute, there was a time when if you had an idea for a new project, a new application, you'd have to wait to go through the hardware acquisition process just to do a proof of concept in a lot of cases. Now with EC2, it's easy. You go spin up some servers, you try it out, and you're good to go. So NetBond has kind of done the same thing for network because we've already put the multi-tenant physical infrastructure in place. All you have to do is go to a portal and deploy these new virtual private network connections. And this could be used for a lot of things like private connectivity to S3, things for archival and backup. So S3 and Glacier for archival and backup. NetBond, you can connect to AWS for the use of EMR if you want to spin up some Hadoop type resources. So, okay. So some use cases. This one is actually pretty cool. VPC to VPC connectivity. As you know, that not everything within AWS can talk to each other. I mean, specifically with VPC and especially across regions. Not sure why that's going automatically. But with NetBond, in this case, if we spin up a NetBond connection in the US West 1 region, and spin up another one in AP Southeast 1 in Singapore, VPC to VPC connectivity just works out of the box. It just starts working. By the nature of the way that route advertisements work, the virtual private gateway sharing its routes with the IPEs in US West propagates those routes out to the entire network, not just the customer data centers, but also to that VPC in Singapore. So it simply just works. And a customer might use this, for example, for data replication. You can replicate EBS volumes. You can replicate S3 buckets, even encrypted S3 buckets. It's data agnostic. You just have IP connectivity flowing back and forth between VPCs. So this is a pretty good use case. Benefits, I already talked, inter-VPC connectivity, shortest path routing between VPCs and other AVPN sites, no tunneling required. So some customers that require private connectivity also want to apply advanced security policy within the VPC itself, just like they do in their own data centers. And they want to do it using tools that they've already invested in. Sometimes they want tools that are a little more flexible than what EC2 security groups or network ACLs can offer. And so this can be accomplished by deploying a virtual router and firewall in a NetBond connected VPC. So first, a subnet is created within the VPC for each isolated security zone that the customer requires. Next, a virtual router and firewall appliance is deployed into one of the subnets. A network interface is created in each subnet and attached to that virtual router. Then, in order to facilitate routing between the subnets, the default route on each of the EC2 instances deployed into the VPC would be set to the private IP address of the virtual router network interface that was assigned to that subnet. And just to make sure that a system administrator doesn't try to circumvent that virtual appliance by changing the routing table, we can apply network ACLs to block all traffic between VPCs. Because you've got that network interface presence within the subnet, you don't really need to route between subnets using the virtual private gateway. So at this point, oh, sorry, one more thing. What this does require is this does require site-to-site tunnels from this VPC and any other VPC that you decide to use this with back to the customer data centers. And this is because that virtual appliance has no way to peer with the NetBond infrastructures, because it's kind of an over-the-top type of solution. So at this point, all traffic has to route through the virtual appliance, including in between subnets. So this could be used to separate lines of business, for example, or just to create multi-tier application architecture and maintain that kind of security policy that customers are doing in their own data centers. Okay. Key benefits: centralized management of advanced security policy between VPCs and other net-bonded sites, minimal number of site-to-site tunnels required, and the added latency of adding the virtual appliance and the site-to-site tunnels is negligible. So this is another way to do multiple security zones, but in this case, it's using multiple VPCs. Some customers would rather use multiple VPCs, maybe because their VPCs are owned and managed by different business units and they want to maintain that separation. Additionally, they might want to avoid site-to-site tunnels, and for whatever reason, they don't want to rely on a virtual appliance deployed in VPC to enforce the policy. Some customers are embracing the cloud with a little hesitation. They want to have their security devices outside just in case. I've never heard of a hypervisor being breached, but if something happened there, they want their firewall to be able to catch it on the outside. So as part of the AVPN service, a customer, come on, build out slide. A customer can create multiple VPNs on the same access circuits that they've got in their data center. I mean, many Mpls customers here, through an EVC or a PVC, you create those virtual circuits. And at this point, you've got multiple VPNs, and we can use this to actually create those multiple security zones by creating a NetBond VLAN per security zone that attaches to each one of those VPNs and ultimately attaches to each one of the VPCs. So now you see at this point, all security policy is actually being enforced in the customer data center. So you might think, what if one VPC wants to talk to another VPC? And if you've got some applications that are latency sensitive, that could be an issue. So if a customer has a data center that's within close proximity to this region, you could enforce all security policy there. However, as part of the NetBond service, we've got another feature called BYOA, or Bring Your Own Appliance, where the customer can acquire colo space in the same data center where we've got the NetBond infrastructure. They can put their own firewall in that space. We're going to give the customer redundant CSP side handoffs and redundant AVPN side handoffs so that you can put your own, or customer can put their own security appliance in between the CSP and their network. So you get this closer proximity enforcement of the security policy. So benefits: no tunnels at all, which is nice. No virtual appliances, minimal added latency when leveraging BYOA. So I forgot to mention one thing. VPC peering. Of course, you can link VPCs with VPC peering. The issue with that is it doesn't work across regions. NetBond will actually enable VPC to VPC connectivity across regions. Transit VPCs, relatively new solution that's really, really cool, but requires at least one virtual appliance, if not multiples, depending on how you're deploying it, and also requires some tunneling via customer gateways to be accessed as part of the public routing domain. Not on the internet necessarily, but still using public IP space and potentially exposed to some of the inherent risks of public IP space. So this solution avoids all of that. All of this is absolutely private connectivity. Okay. So you've heard throughout the presentation that NetBond can provide private connectivity to a lot of different cloud service providers. I won't name them all. Feels unnatural to say anything but Amazon today anyway. But one of them that I will mention is AT&T's Global Mobility Network that we use as part of our Internet of Things ecosystem. Using a NetBond connection to this network can provide private connectivity from IoT devices, mobile devices. And again, because NetBond connections can talk to NetBond connections, taking the shortest path across Mpls, you can connect these IoT devices across the private network to either the AWS IoT platform if you want to connect to public service, or you could connect to private service, set up a VPC with an IoT endpoint within that service. And of course, if the customer wants to set up their own IoT endpoints in their data center, that would work with this as well. So, secure end-to-end private connectivity between mobile devices and IoT platforms. So let me back up. That's Amy's slide. So before I hand it back to Amy, I just kind of want to highlight or reiterate one more time that I believe that NetBond really does now bring network into the realm and in line with other cloud services. The way that it's defined on-demand, self-service, ubiquitous access, all these qualities that have defined cloud, NetBond now actually delivers on. And to me personally, as kind of a tech geek, I like having access to this portal and knowing I can set up, access to resources, in the West Coast, and while that's spinning up, I can, swivel my chair and connect to resources on another CSP in Asia or in Europe and start getting to work there. No longer do I have to worry about hardware acquisition and all the logistics involved in that. So that's what I have, so I'll give it back to Amy.
Well, thank you, Chris. So we're just going to wrap it up with a couple more slides, and then we're going to open it up for questions. And Chris, you're welcome to stay up here. Oh, sure. One thing we wanted to point out real quick is this is a slide of how NetBond connects to Direct Connect versus how some of our other competitors do. And in blue is all manual steps, and in white is the automation. So you'll see, and this is what really distinguishes how NetBond actually connects into Direct Connect, it's all automated, completely automated. And the other thing I should mention is with AWS Direct Connect, there's usually two charges. There's a port charge and then there's a usage charge. We actually absorb the port charge. So you don't have to worry about selecting the AWS Direct Connect port. We actually, that's part of our offer, as part of our managed service. And then we also absorb that cost. So you just have the usage cost. You can see we are very, very automated when it comes to connecting into Direct Connect. So I just wanted to point that out. Next, all the things that we showed you that self-service portal can do, is actually available through APIs. So if you wanted to, you also could ingest those APIs and you could include them into your operationals portal, your enterprise portal, all that's available through APIs. And so just wanted to mention that. And I think lastly is our kind of roadmap. So what I didn't mention is that we actually have a virtual firewall also within our NetBond inline. And it's interesting why we have a firewall, because Mpls, you normally don't need one, but a lot of enterprise customers are still not 100%, with the CSP coming into their VPN. And so that's why they've asked for a firewall. So we provide a virtual firewall, and because we use software-defined networking, it's inline, it's as a service, all those great things. And we're going to be rolling out more and more things like that. So WAN acceleration, just more capabilities that you would traditionally put on your own prem, we're going to have inline as bumps in the wire in our NetBond service. So I think that's pretty cool. And again, we're continuing to expand globally. Love to get your feedback offline, where you'd like us to go, or features you'd like to see in NetBond. And then, lastly, I guess some marketing person put this in here, but we did just win Cloud Computing Award, so we're actually very proud of that. We just won that award recently. And so lastly, we are in booth 2232 on the floor, and so happy to answer any questions there. But we do have a few minutes, so I'll open it up to questions for Chris and I.